Simulating the interaction between multiple characters is challenging because character actions must be carefully coordinated and synchronized. Our system allows us to create a dense crowd of virtual characters interacting with each other. We address the problem by tiling motion patches spatially and temporally. The motion patch encapsulates an episode or event among a small number of characters for a short period of time. Our motion patches are deformable to add flexibility in stitching patches. The motion patch is depicted as a convex polygon that encloses the moving trajectories projected on the ground. The red dots represent manipulation handles that specify the body position, direction, and timing of the characters. The violet line represents the interpersonal constraint that maintains the relative position and direction of a character with respect to the other. The motion patch is supposed to capture an interesting episode that is either important or unusual. We use 3 criteria to detect episodes from raw motion data. The physical contact between characters indicates the occurrence of interesting events. Even though there is no physical contact, it is noteworthy if 2 characters come close to each other and either of them reacts to the other. Even though 2 characters do not come close to each other, it is also noteworthy if 2 characters perform interesting actions simultaneously and they are aware of each other's action. The detection of a noticeable event results in imposing interpersonal constraints, which enforce the relative position, direction, and their timing of actions remain unchanged, though their motion data undergo deformation. The collection of our motion patches exhibit a diversity of human behavior. Given a collection of motion patches, our system randomly samples the position, direction, and timing of patch instances. We can stitch 2 deformable patches if there exist good matches at corresponding entries and exits. Our system inserts deformable patches to the tiling one by one. Our tiling algorithm uses a combination of stochastic sampling and deterministic search to automatically generate the high complex animation of multiple interacting characters. Our system is particularly useful for synthesizing a dense distribution of interpersonal interactions. The tiling of motion patches generates a sequence of actions while maintaining the coherence of interpersonal interactions and avoiding interpenetration between characters. Our system is inherently capable of dealing with dynamically changing environments. Whenever a new patch instance is sampled, the interpenetration with obstacles are detected and avoided. One of the obstacles is tall and the other is shorter. The characters can jump over the shorter obstacle, but cannot jump over the other. The user can influence the generation of animation indirectly by using a variety of environment features or specifying the ratio and preference of actions. The user can directly control the position, direction, and timing of specific patch instances in the tiling. To do so, the user selects several patch instances and arranges them in the spatio-temporal domain as he wants. Our tiling algorithm inserts new patch instances around the user-specified patches to make them fully connected. In this way, the user can control which action to occur when and where in the environment. We capture 2 subjects chicken hopping. The player must stand straight, lift up one of its legs, and hold the ankle with its hands, and hop on the other leg. The players bump each other to make the opponent lose balance. Many of the patches exhibit 2 players bumping, and some patches show one player dashing and the other evading. The user can control a small number of characters interactively. This demo shows 2 teams of players. The user selects the target locations to steer the players. The player bumps its opponent and avoids the fellow. We recorded 50 seconds of the play, and our patch construction algorithm identified 6 2-player patches from the data. We can construct a seamless tile that repeats either spatially or temporally. Spatial repetition of tiles can cover an arbitrarily large spatial region seamlessly, while temporal repetition of tiles generates an infinitely long animation. This example shows the characters interacting with props. The characters are picking up, carrying, passing, putting down, and sitting on boxes at random. In this interpenetration-free animation, The characters are precisely aligned and synchronized with each other when they pass a box from one character to the other.